Good day, everyone. I am Abigail Apostol Tanda, grade 11 STEM, St. Albert the Great. Together with my partner, June Ray Martopaon, we will teach you guys how to solve for the mean and variance of the sampling distribution of the sample mean. In finding the mean and variance of the sampling distribution of the sample mean, we must need an elements of the population. In our case, we decided that our population will consist of the age of each member of the family, which includes cousin 1 whose age is 24, cousin 2 whose age is 22, cousin 3 whose age is 18, and my brother whose age is 14, with supposed sample size of 2 drawn from this population. Since we already have our population, we can now solve for the mean and variance of the sampling distribution of the sample mean. There are 6 steps in finding the mean and variance of the sampling distribution of the sample mean. Step 1. Compute the mean of the population. To compute the mean of the population, we are going to use the formula mean is equal to the summation of the population over the number of elements. Since we are talking about the summation, we are just going to add all the age of each family member, since the x represents the population. So let's substitute. 24 plus 22 plus 18 plus 14 over the number of elements, which is 4. The summation of our population is 78 over 4. And 78 divided by 4 is equal to 39 over 2 or 19.5. Therefore, the mean of our population is 19.5. Step 2. Determine the number of possible sample using the formula of the combination. The capital N represent the population and the small letter n represent the sample size. Factorial means we are going to multiply 4 up to 1, the same as the 2 up to 1. So as you can see, we have 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. We get the result of 24 over 4. Next step is to divide 24 to 4. And the result is 6. That's why our possible sample is 6. Step 3. List all the possible sample of their corresponding means. In our sample, since we have given size 2, we just paired the number of age of each member of the family into 2. That's why we've come up to this 6 pairs, which is 24 and 14, 24 and 18, and 24 and 20, 22 and 14, 22 and 18, and 18 and 14. In our mean, we just simply add the pairs and divided it into 2. 24 plus 14 divided by 2 is equal to 19. 24 plus 18 divided by 2 is equal to 21. 24 plus 22 divided by 2 is equal to 23. 22 plus 14 divided by 2 is 18. 22 plus 18 divided by 2 is 20. 18 plus 14 divided by 2 is equal to 16. And those are the corresponding means of our possible samples. Step 4. Construct the sampling distribution of the sample means. We have here another table, which is the sample mean, the first column, second is frequency, and the third is the probability. The sample mean represent the corresponding means of our possible sample in our previous step. The frequency is the number of times that each sample mean occurs. In our sample mean, we have 19, 18, 16, 16, 20, 21, and 23. In our frequency, since they all occurs once, we just put 1 in every column. And then we add all the 1. That's why we have a total of 6. Since we have the total, we can now get the probability of each sample. The probability of getting 19 is 1 over 6. And the probability of getting 18 is 1 over 6 also. And 16, the probability is 1 over 6. And in 20, we have 1 over 6. 21 and 23 has the same. That's why we can get 1, because 6 divided by 6 is 1. That is the total of our probability. Step 5. Compute the mean of the sampling distribution of the sample means. To do that, we just simply multiply the sample mean by the corresponding probability and add the results. So let's begin. 19 times 1 is equal to 19. Divided by 6 is equal to 3.16. 18 times 1 is equal to 18. Divided by 6 is equal to 3. 16 times 1 divided by 6 is equal to 2.67. 20 times 1 is equal to 20. Divided by 6 is equal to 3.33. 21 times 1 is equal to 21. Divided by 6 is equal to 3.5. 23 times 1 is equal to 23. Divided by 6, that is equal to 3.83. And then we are going to add all those numbers that we get. 3.16 plus 3 plus 2.67 plus 3.33 plus 3.5 plus 3.83, that is equal to 19.49. Therefore, the mean of the sampling distribution of the means is 19.49. Step 6, or the last step. Compute the variance of the sampling distribution of the sample mean. To do that, we must follow these steps. A. Subtract the sample mean from each sample mean. Next, square the difference. And then, multiply the result by the corresponding probability. And last, add the results. Okay, so let's start. Subtract the sample means from each sample mean. So we already have the mean of the sampling distribution of our means, which is the 19.49. And the value of our sample mean are 19, 18, 16, 20, 21, and 23. Let's just subtract those values to our 19.49. 19.49 minus 19, that is 0.49. 19.49 minus 18, that is 1.49. 19.49 minus 16, that is 3.49. 19.49 minus 20, that is negative 0.51. 19.49 minus 21, that is negative 1.51. And 19.49 minus 23, that is negative 3.51. Next step is to square difference. So, 0.49 squared, that is 0.24. 1.49 squared, that is 2.22. 3.49 squared, that is 12.18. Negative 0.51 squared, that is 0.26. Negative 1.51 squared, that is 2.28. Negative 3.51 squared, that is 12.32. The next step is multiply the result by the corresponding probability. And we all know that our corresponding probability is 1 over 6. So we just simply multiply those results to 1 over 6. Let's start. So 1 over 6 times 0.24, that is equal to 0.04. 1 over 6 times 2.22, that is 0.36. 1 over 6 times 12.18, that is 2.03. 1 over 6 times 0.26, that is 0.043. And 1 over 6 times 2.28, that is 0.38. 1 over 6 times 12.32, that is 2.05. Since we already have those values, we just add all the results. So 0.04 plus 0.36 plus 2.03 plus 0.043 plus 0.38 plus 2.05, that is equal to 4.903. Therefore, the variance of the sampling distribution is 4.903.